Okay, so I feel like it might be a good idea to record problem 3 so that we can do it right. Okay, so problem 3, I haven't done it. These are all new numbers for me. I got halfway through whatever, and yesterday in class, but we're gonna do it now. So this is it, but I'm gonna be switching back and forth between this and this. Okay, so what I want to do is rewrite the circuit so that it's something that is, I don't know, easy to tell what's happening. So we've got our, what am I doing? Let's erase point erasing. Hang with me for a second. Okay, this is how I want to rewrite it. First of all, we're going to have a junction there that's going to come down here. And I may rewrite it again. I don't know if this one's going to be good enough for us. This is R5. Here's R2. What do we have? We have R1. We've got this point. We're going to come down and do R3. Nothing there. I'm going to do R4 and R6 there. And that should do it. Okay, so I'm not going to worry about numbers just yet. We're gonna think about this. Is there another way we could do this? Is there another way we could look at it and make sure that we have a nice clean voltage from top to bottom? Well, I think there is. So first we're going to have R2, and then that's going to run into, let's back up a little bit. That's going to run into R5. And that's going to be the bottom of our circuit, and we're going to come back around and go back up to our EMF. Okay, so R2, R5, and from here, we've got a couple of things. We've got R1. So we're going to drop down and do R1. And from R1, we're going to branch off and do R3. And I'm not even going to draw them both. I'm going to just draw that as our R4 and 6, R4 and 6. They combine and that's going to equal R4 plus R6. And there's our R3. So this is really what our circuit looks like. I'm probably going to do our loop methods and junction rules with the top, with this one. That's what we're going to do our loop method and junction rules with. However, we can do our equivalent resistance with this bottom one. And I've already done the first step, right? I figured out what our 4/6 is. And we want to do, I'm just going to write it like that. What about our 3/4/6? So that's going to be equal to 1 over R3 plus 1 over R4/6. And then, of course, that'll give us some number, okay, which we're going to figure out in a little bit. Okay, so now we've got R3/4/6, which is a combination of R3, R4, and R6, okay? All right, what is in series with those is R1. So we can do R1, no, we want to do R1 3/4/6 equals R1 plus R3/4/6. Okay, so there's that. Then we have R1 3/4/6 is in parallel with R2. So 1 over R1, 2, 3, 4, and 6 equals 1 over R2 plus 1 over R1, 3, 4, 6. Okay, lastly, we've got the R equivalent, and that is in series with R5. So whatever that R1, 2, 3, 4, 6 is equivalent, 1, 2, 3, 4, and 6 plus R5, that's going to be our total circuit equivalence. Okay, so do we want to start plugging in numbers to do this? I suppose we should. So let's go down a little bit. And let's get our numbers. So where's that? Come on, baby. Here we go. Okay. 65 ohms. Let me make sure that these are the same numbers I was using earlier. Well, we're not going to have the, my memory's terrible, so I'm going to write down R1 is equal to 65 ohms. R2 is equal to 80. R3 is equal to 136 ohms. R4, 127 ohms. R5 is 60 ohms. R6, 157 ohms. And while we're here, let's write down our EMF at 63 volts. And away we go. So let's do it. We'll come back here. Okay, R4/6. R4/6 is 4 plus 6, 127 plus 157. 127 plus 157 ohms. And I have a calculator in around here somewhere. But we could do it in our head. It's 14 plus 8, 184, 284. All right. 284 ohms. Okay, looking good. Now we're going to do, let's erase this. And we're going to do equals 1 over R3. That's 1 over 136 plus 1 over 284. And that's 1 over ohms. So then we can 1 over 284, 136, 1 over that, add them together, and then 1 over that. That's 91.96. Okay, I'm going to just do R346. My calculator allows me to say this is 91.96. 91. And since we're doing web work, you know, unless it's a really high 9 or a low 1, I would carry it out, 5s and 4s and 6s and 7s. I would just keep going until you get a 1 or a 9 and then round up or round off. Okay, so 91.96, good. All right, now we want to do R1346. That's this one here. R1346. R1346 is going to equal this R346 plus R1. So we're going to take that. We're going to add R1 is 65. 65 plus 156.96 ohms. Okay, to do it properly, we want to do 1 over R1, 2, 3, 4, and 6. And that's going to be 1 over R2. R2 is 80 ohms. So 80 ohms. And we're going to add our 1346. So 1 over 156.96. 156.96. And that's 1 over ohms. So when we finally get an answer, we can flip it. Of course, my computer, my calculator, whatever, is going to do this for me. 80, 1 over that. Add that together. Flip that back, and I've got 52.99. So R1, 2, 3, 4, 6 equals 52.99. Don't round up yet. Okay. Now, the last thing we're going to do is get our REQ. Our REQ for this situation equals R5 plus that. R5 is 60 ohms. So I'm going to add 60 straight up ohms. 112.99. 112.99. I'm going to say, I'm going out on a limb on this one, and I'm going to say it's 113, okay? So let's do R equivalent equals 113 ohms. Okay, we can write that here. REQ equals 113 ohms. Let's move down. Now, V equals IR. So solving, we get I equals V over R. And of course, our V is an EMF. So that's our EMF. What is our EMF? 63 volts. And we're going to do that over our net REQ, our total equivalent resistance for the circuit. That's 113 ohms. And that'll give us our 1 over that times 63. That's 0.55756. And I'm going to stop there. 0.55756. There's a 4 at the end of that, but I have a feeling that we'll be okay if we stop at the 6. Web work isn't going to kill us, I don't think. Okay, so what is that? That's in amps, right? All right, so what I'm going to write down 113 is our equivalent resistance. It's 113 ohms, and our current through the whole circuit is 0.55756 amps. Okay, crazy that we're going to that amount, but we are. So now let's go back over here, and we'll put in our equivalent is 113 ohms. Okay, and we're going to do our equivalent amps. That's 0.55756. And then I have this option, but you don't. I'm going to say correct answers. No, let's not. Let's just do check answers, and we'll see if we're correct. We are correct. So the first two are right. Good job by us. Let's continue on. Okay, will we be doing these in order? No. Why not? R5, see that R5 right there? Is the last thing that happens before it runs into, the current runs back into our battery. That current for R5 has to be the same as the current that gets split up across R1 and R2. So R5 has the same current that we have going through the entire circuit, which is 0.55, 0.55, what was it, 756? Let's see. Let's check our answers. Okay. So, nice job by us. And now we can start cutting it up. We're going to go back to our diagram and start knocking the rest of them down one at a time. So let's come back here. We've got our R5 current solved. Okay, so there's I5. All right. I5 happens to be leaving Interstate 5 in Southern California. Okay, I5 going down that way, and it's going to split off, and we can call this current I1, and we can call this current I2, and we know that I1 plus I2 by the junction rule. So let's start doing our analysis. We'll work up from here. I5 equals I1 plus I2. All right, well, there's one thing to know. And we're going to do a loop. We're going to do a loop right here. This is our loop 1. So let's do that loop. We have I2. Yeah, let's write loop number 1. I2, R2. That's negative because it's going in line with our loop. Okay, we've got our loop going clockwise. I5, R5. That's also going to be negative. I5, R5. And then, of course, we have our EMF that we're going to add up together. And all of that is going to equal 0. Okay, what is the question, however? We want to know I2. So we solve this for I2. I'm going to move this whole term to the other side. So I have I2 is equal to our electromotive force minus I5 R5. And we're going to divide out by R2. We know all of those things. The only thing in this equation that we don't know is I2. So we now will have I2 because I2 is equal to, what is it, 63? 63 minus I5 R5. R5 is 60. I5 is that 0.55756, I think. And then we're going to divide out by R2, which we know is 80. So that's going to give us I2. And let's plug that into our sweet, sweet calculator. Oh boy, I hate when I mess up. 63, enter. Okay, I mixed them up. I'm going to divide, I'm going to subtract and then divide by 80. 0.3693. I don't feel comfortable with that. Let's try it again. 60.55756 times that, subtract that, and 80 divide. 0.36933. And that's, of course, in amps. So 0.36933 in amps. Okay. Here's a sweet move. I1 is equal to I5 minus I2. So I1 is equal to 0.55756 minus I2, which is 0.36933, and that's in amps. So I1, 36933, let me flip them. Okay, that's a negative, and I'm going to add 0.55756 to that. That's 188.23. So 0.18823. That is my I1 in amps. So let's write I1 here is 0.18823 in amps. So we've done quite a bit. Yeah. So what have I done? I'm going to write on my little piece of paper so I can go toggle back and forth. I've got I total, which happens to also equal I5. I've got I2, which runs across R2, I2, and that's equal to 0.3693, let's say, amps. We can drop that last 3. I1 going across R1, that is 0.1882. Keep the 2. Okay, so we can go back to, well, sorry about that. We can go back here, and we've got I2 and R2, R1 and R2, I1, R1, whatever. 0.1882, and we're going to do 0.3693. Okay, let's check our answers. Okay. So what is our next? What are we going to do next? Do I want to look at this diagram to figure out what I'm going to do next? No. I certainly do not. I want to come back to this. Let's see, what's next? Since we have these and we've done loop 1, I'm going to erase Okay, I thought that might be better, but point erasing I think is the best. We're going to erase that because you guys already wrote it down. You're so good. Okay. What's our next loop? We can do this loop right here. This is loop 2. Okay, loop 2. We know I1, we know R1. Let's label this as I3 going down. And that's pretty much it. So let's do our loop 2. Loop number 2. We'll start here at that point and we'll come back around. So we're going with I1, so that means it's a negative I1 R1. We're going with I3 across R3, so that's I3 R3. And we're going against I2 R2, so we're going to have to add I2 R2. And we know all of that equals 0 because of the loop, the way the rules work. Kirchhoff, thank you. And so now, what is it that we really want to know? Let's talk about what we do know. We know this, we know this, we know this, we know this. We also know this. So all we have to do is solve this equation for this I3, and we're good. So we'll move this whole term to the other side and divide out by R3. So let's do that. I3 is equal to I2 R2 minus I1 R1, and we're going to divide out by R3. Now, let's plug in some numbers. I2, 0.3693. We're going to multiply by R2. R2 is 80 ohms. Let's drop these guys. I have a feeling we don't want to carry around our units for the time being. Let's just drop them. I1, 0.188. We'll put a 2 on there. We're going to multiply that by R1. R1 is 65 ohms, and then we're going to divide all of that out by R3, which is 136 ohms. That's going to give us our current in amps. And let's plug in some numbers. 0.3693, enter, 80. 0.1882, enter, 65 times that. We're going to subtract it. And then we're going to divide all of that by 136. And that gives us 0.127. And I'm going to say 73. Okay, so there's our I3. And let's just write it up here nice and neat, because that's right? Everything I do is so neat. You can tell by this scribble scrabble written all over this page. 7.3 amps. I try to do it without making marks, and if I press my hand down firm, I don't make any marks. Okay, so let's erase our loop 2 because I think we've gotten everything that we need out of loop 2. And we know the R3 current. So good for us. We can come back. Let's go back. R3 current. Oh heck, did I write it down? I didn't write it down. 1273. I3 equals 0.1273 amps. Not 0.0, 0.1273. Let's check that. Okay. Now, I have a question for you guys. Is there a difference between the current that's flowing through R4 and R6? Let's maybe look at this picture. We've got current divided. Here at our junction, we've got I1 going in. We've got, we've got I'm going to call it, which one haven't we done? Let's do I5, let's call it I4. Okay, so we've got I4 here, and it's going to be going through R4 and R6. How can we use the junction rule to help us here? So I1 is equal to I4 and plus I3. And we already know I1 and I3, so I4 is equal to I1 minus I3. So, and it's not going to change, right? That current is going to be the same across both R4 and R6. So I4 is equal to I6 as well. So once we get this little thing solved here, we're golden. So what is this? 0.18823, and we're going to subtract off 0.1273, and both of those are amps, of course. And that gives us I4 equal to 0.1823 plus that 0.0609. That's as far as I'm going to go for our I4, which also happens to be equal to our I6. So I'm going to write that down on my page here, 0.0609 amps, and we're going to go back up to our 0.0609, and we're going to put that in here too, 0.0609, and we're going to check our answers, and lo and behold, we have all of it. We can submit this, and we're totally done. That's it, guys. Thank you. I love doing these recordings, and hopefully you'll get something out of it.